Okay, we're going to be looking here at 2.4 section in Math B30, or sorry, C30. And what we're looking at today is we're looking at drawing a reciprocal function and how we sketch, excuse me, sketch it by hand. So what we always do in this case is we pretend, if we're doing cosecant or secant, I'm not talking about cotangent here. If we're doing cosecant or secant, we just simply pretend that we take the reciprocal function of it and draw that. So we know the reciprocal function of cosecant is sine. So we just plug in sine there and we do our normal drawing like we would do as we did in section 2.3 and draw this sine graph. But we do a pencil drawing of it or a light drawing of it as a guide. So here is my guide that I'm going to set up using pencil here. So first thing, the 2 in front tells us that it has a maximum amplitude of 2. So let's put 1, 2. 1, 2. 1, negative, and 2, negative. So we're good there. And now, having that, we have no vertical shift, so we know that this line here is now a 0 line. And we can probably, because that's our 0 line, and there's no vertical shift, we would have looked there, we can actually put that one into pen already for ourselves. Okay, now we have to determine the period of the positive period and the negative period that we're going to be drawing, because like I said earlier in my tutorials, the book always draws the one positive period, just this part here. But I like to draw the negative and the positive period. It's just more complete graph. So that's what we're going to do. So we then say that this is a sine graph, so we know that sine's normal period is 0 to 2 pi. So we would say, okay, well, that would mean, I'm just going to move this here so we can work it out on the bottom a little bit. We move that up a bit and slide this over a bit. So working it out, you would just say, okay, normally we have from 0 to 2 pi, and we have that stuff in the middle, 2 times x plus pi over 4, close the bracket, and all the way to 2 pi. Now you can do this in degrees as well, and I haven't shown any degree ones in my tutorials, but I imagine I probably have in the class. So what we do then is we solve here for isolate x by itself. So divide each one by 2, everything by 2 here. So 0 divided by 2 is 0. This divided by 2 is x plus pi over 4. And 2 pi divided by 2 just gives you pi. Okay, so now we have to subtract a quarter pi from each. So negative a quarter pi out here. And x is now by itself. And out here, pi minus a quarter pi. Well, how many quarters are in a unit of 1? Well, 4 are. So we take 4 minus 1, and that would be 3/4 pi. Out there. So then we know, and I'm going to plug in my notches here. My 4 notches for the positive and my 4 notches for the negative period. Okay, so now that I have that, I now know that this point here is negative pi over 4, and this point way out here is 3/4 pi. So we want to get the middle point, halfway in between. So how we do that is we could do the negative 1/4 plus the 3/4 divided by 2. So this would be 2/4 divided by 2, or multiplied by 1/2. So that would be 2 over 8, or 1/4 if you like. So that middle point is 1/4 pi, or pi over 4 if you like. So if we add another quarter pi, well, we could figure out what the middle is here, but we can do that one in our head. 1/4 plus 3/4 is 1. 1 divided by 2 is half pi. So this is pi over 2. Now we know the gap in here from here to here is 1/4 pi. So we just simply subtract 1/4 pi here. So it'd give us 0. Subtract 1/4 pi out here, that would be give us negative half pi. Negative 3/4 pi. Negative pi. And finally out here, an extra quarter would be negative 5/4 pi. Okay, fraction skills are always helpful. Okay, now we know where our 0 line is. So we can put the hard black line in for the 0 line. Okay, now we have to draw the pencil drawing using our guidelines. Now our guidelines that we're using here, and where's my pencil? There it is. Okay, the guidelines that we're using is we're using this and this is our starting point. That's just for a reference there, where the true axis is. So we start drawing a sine graph. Okay, there's the 0 point, and the first notch has the max, then a 0, then a minimum, then a 0. That's the positive point of the positive period, pardon me, of the sine graph. It would look like this. Okay, having done that, we can continue on and do the other side here, the negative period. So we go down here, there's our point, down to here, 0 there, maximum up here, and there's a 0 as well, and connect those up for our sine. Okay, so that gives us our guideline now. Now what we do is wherever we see a 0, we put an asymptote in black for the sine graph. So there's an asymptote here. An asymptote here at negative 3/4 pi. An asymptote right in here at the negative 1/4 pi. An asymptote at the positive 1/4 pi. And an asymptote out here at 3/4 pi. Okay, and then we just make our U's on our hills. Now, let me just check my view here. We would draw these U's in here. And this would, the U's would be the actual graph that we would see if we were to draw or have this graphed on a calculator or something like that, which I'm not going to be able to do in this case. I'm going to run out of time, but we're just going to finish drawing our U's in here. And then if you were, you could erase your sine graph there if you like, but you can leave it as evidence of work that you've done as well. You know, when I'm correcting and things like that on exams, I don't mind you leaving it in lighter pencil. Just make sure that this is the obvious graph that I want to see here. Okay, and that's an example of drawing one of those graphs. Okay, later, in our next tutorial, we'll probably move on now into, so we've had a lot of experience drawing these types of shifted graphs and so forth. And when you get into the reciprocal functions, you don't really change anything much. You just draw that typical graph there and add U's on it for the cosine and sine, cosecant and secant graph. Now for the cotangent graph, you just draw a typical, you do a typical shifting thing, except you draw a backwards tan graph. It has a different curve to it. So we're going to probably go into section 2.6 in our next tutorial, solving equations that have trigonometric functions in them.